Now, in this video, we will going to take up one more problem on the projections of points in the second quadrant. A point capital P is 45 mm above HP and 60 mm behind VP and 30 mm from RPP. Draw the three principal views of the point. Also, state the quadrant in which it lies. So, here to decide whether this point is in second quadrant or not, the condition has to be above HP and behind VP. As we see, it is behind VP. Obviously, it should be behind RPP. So, behind RPP means it should be the right side view. So, here the distance is 45 mm above HP. When you look from the front view, I can see the distance above HP. So, the distance when it is projected onto the vertical plane, you are going to get this distance is 45 mm above HP. So, that I can see from the front view. And also 60 mm behind VP. So, when you look from the top view, I can see the distance 60 mm behind VP, and when it is projected onto the horizontal, when you look from the top view, it has been projected onto the horizontal plane. So this point will going to become small p. So that distance will be 60 mm behind VP. And 30 mm from RPP, that is 30 mm behind RPP. When you look from the front view, I can see the distance 30 mm from RPP. So that distance will going to be seen in the vertical plane, and also 30 mm from RPP. When you look from the top view, I can see the distance 30 mm from RPP. So that distance will going to be seen in the top view also, and this is being projected here. So now, when you look from the side view, that is the right profile plane, we can see the distance of above HP, that is 45 mm. That distance can be seen here, and also, when you look from the right side view, I can see the distance 60 mm behind VP. So that distance can be seen here. So when you cut it here and rotate HP to the top side and right profile plane to the right side, so we can see that intermediate position wherein both VP and HP is coinciding, and the right profile plane will be going to shifting towards the right side. So then when you go to the next position, this will going to be the final position wherein both VP and HP will be on the same side, and also right profile plane to the right side. And so the distance above HP, which is 45 mm, is seen in the vertical plane. Since the image is in the vertical plane, so that becomes P dash, and the distance behind VP, which is 60 mm, is seen in the horizontal plane. Its horizontal plane is also above the XY line, so the small p will be on the same line. So the distance with respect to the profile plane, so that is 30 mm behind RPP, can be seen in both VP and HP. So from this line, you will going to measure that 30 mm and you will going to mark this line. And when you are looking from the profile view, I can see the distance above HP, which is vertical. So that vertical distance is also seen here, and the distance behind VP in the horizontal plane, it is in the vertical line, and when it is projected, and you are going to get this here, and then draw a 45-degree line to this vertical line. So when you draw this, so this vertical distance has transferred to the horizontal distance, and where you have the front view, on that line you will going to get the side view. So you are getting the side projected point here, so you are going to get P double dash. So this distance is above HP, and this distance will going to become behind VP. Now we need to write the final solution. So to do that, first we are going to draw the XY line and the X1 and Y1 line, and identify the planes VP, HP and RPP. Here HP we are put it in bracket basically because the HP is the plane which has been rotated, because VP is always fixed in all the four quadrants. So in the first quadrant also we have fixed the VP, and in the second quadrant also the vertical plane is fixed. That is quite evident when you see in this particular position we are rotating only the horizontal plane, and VP is fixed, and right profile plane is also been getting rotated. Now we go to this, and the distance with respect to the profile plane can be seen in both VP and HP. So from X1 Y1 line, you measure the distance of 30 and you draw a vertical line parallel to X1 Y1. Then you measure the distance of 45 from this point, and you mark this point as P dash, because the image what you get in vertical plane is always P dash. In general, the distance with respect to VP can be seen in HP, and the distance above HP can be seen in the vertical plane. So in general, the distance with respect to HP is in vertical plane, and distance with respect to VP will be always on the horizontal plane. And the distance with respect to profile plane can be seen in both VP and HP. So this is the general condition even in the first quadrant also. Now, when you see the distance 60 mm behind Vp, from this point you measure 60 mm and you mark this point, which is small p. Then draw a 45-degree line adjacent to HP. So in here HP is also above XY line. So draw a 45-degree line adjacent to HP to the right side, and then always you project the top view point onto 45-degree line. When you do that, the distance behind Vp, which is vertical here, has transferred to horizontal distance, and where you have the front view, on that line you are going to get the side view. So you draw a horizontal projector from P dash and draw a vertical projector from this 45-degree line. Both these two lines will going to intersect at this point, and you mark this point as P double dash. Since this point P lies in second quadrant, as he has given in the problem, to identify the quadrants. Now also state the quadrant in which it lies. Now we will going to try to solve the problem by using the AutoCAD software. So first we will go to the AutoCAD screen and switch off the grid mode and type the command limits. So specify lower left corner 0, 0, enter. Upper right corner 297, 210, it is the A4 size sheet. Then go to zoom all, because in the examination we need to solve the problem, take the printout in A4 size. So specify first point, you select some arbitrary point and click on the first button of the mouse and put on the ortho mode on, draw a horizontal line, take some distance and click on first button of the mouse and take the cursor to the top side, take some distance and click on first button of the mouse. Now I want to draw a parallel entity. I want to draw a vertical line parallel to this vertical line. So go to offset, take the distance as 297 and you select this horizontal, specify offset distance. You select this vertical line and offset to the left side and click on the first button of the mouse. Again, by default it is exit, you come out of this. Then you want to offset this horizontal by 210. So since the previous command is offset, again you select the offset command by press enter key and type 210 and you select this horizontal line and click on this and take the cursor to the top side and click on the first button of the mouse. As we see by default it is exit, you just come out of this, then go to zoom and take extents. So till they extend to the entity which we have drawn, you will going to see that. Then go to zoom 0.6x, then go to fillet and set the radius. By default it is always 0 and the mode is trim. You select this vertical line and then the horizontal line, then go to fillet, select this and you select this, then you select this and you select this. So you're going to get the A4 size sheet. Then go to zoom window, then come down to this problem. So a point P is 45 mm above HP, 60 mm behind Vp and 30 mm from RPP. Draw the three principal views of the point. Also state the quadrants in which it lies. So here go to the text. So select point start point, specify height, take the height as 4, rotation angle as 0, type the problem number 3 and here a point 45 mm above HP, (60 mm behind VP), and then 30 mm from RPP and 30 mm from RPP. Draw its projections and name the quadrant. Draw the three principal views of the point. Also state the quadrant in which it lies. Draw the three principal views. Draw the three principal views of the point and state the quadrant in which it lies. So this is the problem. So when you see the final solution here, this will going to be the final solution. We have the XY line, we have the X1, Y1 line, and you have to identify the planes VP, HP and RPP and identify by these things by color. So to do that, so first we will go to zoom window Now first we are going to set the layers now. So first go to layer, so click on new layer, type the layer by name XY, then go to layer, type front view, then go to layer, click on new, type top view, then go to new, then type it on side view. So layer 0, line weight has to be 0.05, so by default it will going to be 0.05 now. So layer XY, line weight is 0.13, so that is the XY line weight thickness. So front view should have a magenta color, yes, select this. Then the top view has to be red, select this, okay. Then the side view has to be blue, you select this and say okay, and then close it. Now the current layer 0 will going to have a line weight of 0.05. So all the lines henceforth, whatever you do, it will going to be drawn in 0.05. So here you just switch on the ortho mode, drag, select some arbitrary point and click on the first button of the mouse and drag the line to some distance and click on first button of the mouse. Again enter, again you go to line command, select some arbitrary point and then drag right from here and drag it to the downside and you click on the first button of the mouse. Then go to zoom previous, then go to move, select this entire thing and move it down. Now you will going to take the distance with respect to the profile plane. So go to offset, which is 30 mm, or first we will going to identify the planes, go to dtext, so specify start point, select some point, take the height as 3 and the rotation angle as 0 and you mark this as VP, and then you click it here and identify as HP in bracket because the HP is the one which has been rotated. Then RPP will going to come on the right side and you type RPP now. Then go to offset, take the distance as 30, select this vertical line and offset here. Then go to offset, take the distance as 45 mm above HP. So go to offset, take the distance as 45, you select this line and offset it here to the top side. Again go to the offset, take the distance as 60, so type 60 and enter, select object to offset, you select this line and offset. Since by default is exit, you just press enter key. Now you will go to trim. Now you select this as the cutting edge, enter, object to trim, you select this line and you select this line, then again enter, then go to trim, select this line and this line as the cutting edges and then trim this line and this line. So object to trim. So then go to line, take int of this and take at the rate, take the distance as 100 less than angle 45, then go to line, take int of this and from here draw perpendicular to this, and then go to fillet between this line and this line and fillet between this line and this line. Now you trim all the extra lines. So you break, select this line, you break it till outside, again you select this, break it and you take it outside, then you select this and you break it to the outside and you select this and break it to the outside. Then go to move, switch off the ortho mode, move this text somewhere here, then VP here and then HP here. Then go to zoom window, you select this and take it near to the screen and then go to break this line outside here. So now we need to go for the donut. So go to donut. So by default inside diameter is 0 and the outside diameter is 3, and take the intersection point of this and go to int intersection point of this, center of donut, then go to intersection point of this as this point. Now we need to write the text as he says a point. So here what he has considered, the same point we are going to consider, he has considered as P. So now here we are going to go for d text. So specify start point, I am going to consider this point and height is 3, enter, rotation angle of text as 0, x, you mark this as y and you take the cursor here and you mark this as x1 and you take this cursor here and you mark this as y1 and here you put up the caps lock small p and this will going to become p dash and this will going to become p double dash. Then go to zoom window, then bring it near to the screen, then go to move, select this, move this x1 and then you move this y1, then x you move, then y you move, then P, bring it near, then P dash, you bring it here, then P double dash, you bring it here. Now we need to go for the changing the layer. So first you select between these two, go to CH, go to layer, make this layer as XY. So the line weight will going to change to the 0.13. Then you select between these two. This is the top view. You select this CH and you go to CH layer, go to layer and make this as the top view. Then similarly you select this line and this text VP. So also you select this, go to layer, you make this as front view. Then you select this and you select this too. Then go to CH, go to layer and make this as side view. So we're going to get this. Now we will going to write the dimensions. So to do that, so go to dim DDIM, set the dimensioning variables now. So go to modify, go to lines. So here offset from the origin as taken as 2. Then go to symbols and arrows, take the arrow size as 3. Then go to text, text as height as by default as arrow size 3. Then go to vertical, you make it as above. Then offset from the origin as 3. Then align with the dimension line. Then go to the primary units, take the linear dimension as 0 and say OK and then say close. Now we'll go for dim. Then take center of this and then intersection point of this. So we're going to get 45. You click on this, then go to center of this and take INT of this and then INT of this. So we're going to get 60. Then go to center of this and then go to INT of this. So here, then angular, so A, select this line and you select this line. So you're going to get this as 45 degree. So then you come down to the previous. So then go to zoom previous, escape from the dimension mode, then go to leader. So here nearest point on this, so switch on the ortho mode, take this as the direction of projection, annotation, enter, option, enter, then text none. Similarly leader, take nearest on this and drag it, annotation, option and none. Then go to leader, nearest on this and take this to the top, annotation, option and none. So then go to explode X, select this line and you select this line and then go to erase, erase this and erase this. Then go to move, select this entire drawing and take it nearer to the point, and then we will going to check finally how this output will going to be with your drawing. So this is matching with this particular drawing, and now this is how you will be able to get the drawing completed on this AutoCAD screen. So